Okay, so I don't know why I'm doing this, but I'm doing it. 721. So I have a calculator in mind. So this one we want a percent decrease. I have to write with a pen, and here's a pen. So we want the percentage. So and how long to the first trip to third, second trip. So second is the new. This is the original divided by the original. So it's just a matter of now putting this in your calculator, and you're going to get 35.8 minus 36.5, and you're going to get a negative number, and that makes sense because it's a percent of decrease, and we're going to divide that by 36.5. Shoot, I made a mistake. 35.8 minus 36.5 is equal to divided by 36.5, and that's going to give us negative 0.019178, and we're not going to go that way. Let's just move this 2 decimals over, and just to be better, it's going to be negative 1.92. That would be the rounded version. Oops, percent. Okay. All right, question 2. Where was I? Oh. So this one's calculate the percent of increase. So it averaged from 80 and it went over to 85. Okay, so again, these ones, hopefully you realize this is the new, old, divided by the old. And it's going to be 5 divided by 80. And that's 0.065. 625, sorry. I'm going to change that percent, right? And that's going to become 6.25%, and then it's increase positive. And that should be pretty straightforward. 3. Again, another 1% of decrease, and I know I said in class to let's change this number. So the original price was 342, and sorry, the new price was 342. Let me rephrase. The new price is 500. The original price was 342. No, sorry, you're gonna kill me for this one. So the price of whatever this is of an item, the new price this week. So you go to the store, and it's $342 today. But last week you paid 500, so that's why you're upset. So new. The old price was 500, which is what you paid for last week. Now divide this by 500. So there was definitely a decrease in price, and you're killing yourself because last week you paid much more. So 342 minus, I never get a calculator that works, minus 500 equals, divided by 500 equals 0.316 negative. So if you change that to a decimal percent, it's going to give 31.6%. So a decrease of 31.6%, and you're very angry because you could have paid this if had you waited a week. Let me just pause. Question 4. I'll tell you the joke later. Question 4. Again, we want to find the error. Is the same thing. Okay, so I know we didn't talk about this in class, but it's the same thing. So if you wanted to produce something, an NaCl, a combination of those, and you want to produce 3 grams, that's what you wanted, but you didn't do that, you actually got 2.8. Obviously, there's an error, and we can find the percentage. So the percentage would be, the new was this. We were supposed to get the original, which is 3, and we divide this by 3. And obviously, we didn't get 3 grams, we got 2.8 grams. So 0.2 divided by 3 is 0.066. Let me just go a little bit like that. One more. Change that to a percent. Move 2 over. And it's negative. So the error here was negative 6.6% or 6.7, depending if you round. Okay. 5. Car's moving. It's doing 70 kilometers an hour, and it's going to increase by 40%. So what's going to be the new percent? So if it's at 70 kilometers, and if you're going to increase by 70%, we're going to multiply that by 140, right? So the new speed of the car is going to be 70 times 1.4. So now the car is really fast. By the way, this is not miles, so don't get too This is 98 kilometers an hour. Okay, 100 kilometers about, what, 55 miles or something. So now it's at 98. That's a highway speed, right? It's on the highway. And then when he goes from the highway back to the regular roads, right, like neighborhood roads, it drops to 50 kilometers. So what was the percent of decrease? So first you have to do this, and then we're going to do this. So the new speed is 50 kilometers. The old speed was 98, and we're going to divide that by 98. And obviously it decreased, right, because we went from a super fast speed, 98 kilometers, not super fast, but fast. So 50 minus 98 is negative 48. Negative 48, and we're going to do, what the heck? Hang on a sec, 50 minus 98. Enter, divide that by 98, so it's going to be 0.4898. Let me just write that, okay? So, and if we change that to, it's going to be negative, by the way. So the speed decreased by 48.98%. Okay, and that was number 5. Number 6, something about carbon dating, something that's really old, by measuring the C14 isotope, etc., etc. So something that was found and examined has decayed by 99.7% to 0.08 800 grams. What was the original mass? So if it lost 99%, right? So let me get this right. So I know it's going to be something. It decayed by something. So something that decayed by 99. Hang on a second. I have to think about this for a second. So that means that this represents 3% of it, right? So if you had something, here's 0. Let me put percent, right? And then and think of this as the item here, right? So it's decaying, it's losing its mass, it's losing its mass, it's losing, and over the years, all that we have left is this much, and that represents. So it lost 99.7%. So it really lost a lot of its mass, and it's got a very tiny mass. So what's left over here? 0.800 grams, right? Not even a kilo. So the mass or the weight that it has is 0.800 grams. So we're gonna write that this 0.3%. So let me do this way. 100% minus 100%. I'll put just one decimal, minus 7. So we're gonna left with 0.3%. All right, and then we're gonna change this, change it to a decimal. 1, 2, and it's gonna be 0.003%. That's a decimal. So 800 grams represents this much times x. We're gonna divide both sides now by 0.003. 0.003, and the original weight of this thing, whatever this was, divided by 0.003 equals 266 and I'm just going to round it, 67 grams. So at one point, whatever this organic material was, weighed 266 200.66.67 grams. Okay, and obviously through the thousands of years, it decayed, and it lost 99.7, which so the leftover here represents 0.03 or 0.03%, 0.3%. Okay. 7. An experiment with a bacteria, strained bacteria, the radiation shrinks 15% to size of 300. So if it shrinks to 15%, I'm left over with 85%, right? So this 300 represents 85% of the population. What was the original population? Well, 0.85 times the original population gives me 300, right? So if we divide both sides now by 0.85, clear. 300 divided by 300 divided by 0.85. The original mass of this thing was 352.9 bacteria. Can you have 352.94 bacteria? Or I guess we might have to round it to 353 bacteria. Okay, the population with 353. All right. Can you have half of bacteria? I have no idea. And last question. What is the error in the estimate? Okay, so again, this goes to this. All right, so bunch of bananas are low to. He thinks it's 1,200 grams. When he goes to register, he weighs at 1,000. What is the percent of error in his estimate? So, tough to find who's the new and the original. So, hang on a second. Well, I'm going to say that the new is the 1,200, his estimate, and the original is the actual weight, which is 1,000 grams. So here, tricky question. This is 1,200 grams. This is 1 kilo, and 1 kilo is the same thing as 1,000 grams. So he was over, right? So it has to be a positive number. Therefore, that's why I know that this 1,200 will come first. Because his error was, let's see, 1,200 minus 1,000 is 200. Divided by 1,000 equals 0.2, which equals 20%. So his error, his estimate, he was off by 20%. Okay, so hopefully this helps a little bit. Sorry it wasn't too clear on a couple of questions, but I'm pretty sure you'll understand it. Short video.